How to identify hazards. The first step in the risk management process is the identification of workplace hazards. This means looking for those things at the workplace that have the potential to cause harm. To begin identifying hazards, simply ask the question, does this task, activity, situation, event has the potential to harm a person, property, environment, and/or system? Another way is to ask the question, what if? For example, when inspecting a construction site, ask, what if a worker walks without hat in the industrial premises which is either under construction or renovation? Answer may be, in absence of hat it is possible that any falling object may cause harm to worker. So falling object is hazard to a worker and hat may protect the worker's head. These are proactive ways to identify hazards. Hazards can also be identified from records of past accidents and near misses. What if? Analysis is a structured approach to identify hazards and improves the chances of identifying all of the hazards in the workplace. Persons can ask themselves, is this activity safe? What if this or that occurs? Then, what will happen? The following are the other most important hazard recognition methods. Pre-use analysis can be applied before any new equipment, device, instrumentation, personal protective equipment, machine, tool, plant facility, etc. are used. This method is applied before exposure to hazards. Multi-step planning process is applied before hazard exposure and applied to every task, job and activity. To apply this method simply asks a series of questions before doing the task, job or activity. The question should be similar to A. What am I going to do? B. What is the purpose of doing this job, task or activity? C. How will I do that job, task or activity? D. How could I get hurt doing this job, task or activity? E. What will I do to prevent accident, injury, illness, health? Work permit is issued before the job, task or activity done. Some questions asked and a checklist shall be completed to assure that hazards are not overlooked. Generally, the checklist includes the analysis of toxic gas, such as carbon monoxide, H2S, oxygen sufficiency, flammable gas concentration, etc. Equipment inspection is implemented to any equipment before it is used or put into operation. Equipment inspection is planned and organized to check overall equipment conditions, safety protective equipment, guarding, emergency stop, etc. Suggestion method encourages to propose or suggest potential hazards and controls that are contained in a job, task or activity. Workers consider their past time experiences on the shop floor and field to give suggestions. This method can be used for improving current hazard identification list. Safety patrol can be carried out by every worker in the plant site, not only by persons who are in charge of health and safety matters. Safety patrol may be done during an equipment running, plant operation, plant shutdown or whenever it is intended to identify potential hazards. Visual inspection and observation is the most common and simple way to begin to look for hazards by regular walk-through visual inspections of the workplace. Look at each task the workers do, to see if any hazards are present, such as handling loads, using chemicals or equipments. It may also be helpful to observe workers performing their tasks and the activities involved, such as setup, operation, cleaning, maintenance and inspection. This will provide the opportunity to see whether the documented procedure for performing the task is being followed by the workers, or whether workers are taking shortcuts or speeding up work, e.g. by removing guards, etc. Structured approach to improve the chances of identifying all of the hazards in the workplace. It will help to take an additional structured approach. It is done by dividing the workplace into groupings such as locations, such as offices, grounds, warehouse or wet areas, functions or production processes, such as administration, cooking, washing, cleaning, receiving, forming, or finishing, roles, such as electricians, office workers or drivers, technicians, tasks, such as working on the lathe, loading the truck, decanting a substance or data processing. Other ways to help identify hazards include consulting workers about problems they have encountered in doing their work, Any near misses or events that have not been reported. Symptom, experience, such as pain and discomfort in body parts, or changes to vision, hearing, and skin conditions. Conducting a health and safety audit. Seeking information by undertaking worker surveys, e.g. body maps and discomfort surveys. Consulting with workplace health and safety representatives, WHSRs, and workplace health and safety committees. Knowing the industry's experience of common potential hazards. Acquiring information from designers, manufacturers, suppliers, and other organizations, such as unions, employer bodies, and health and safety consultancies. Testing. Measuring and sampling by means of analyzing records and data covering incidents and near misses, worker complaints, sick leave and staff turnover, maintenance records, results of surveys, audits or inspections. Some workplace activities or arrangements may create or increase hazards, if they are not properly managed or guided. For example, sawdust used by worker in the spillage of nitric acid releases dangerous fumes of nitrogen oxides which are recognized as brown to yellow color fumes. The figure on the left demonstrates this. When collecting information to identify hazards, consider the following. Competency and level of training of workers and its adequacy. How people actually use, clean, service or repair equipment and materials. How suitable the things used for the task are, and how well they are located. How people could be hurt directly and indirectly by the various workplace aspects. How waste materials are or should be disposed, the life cycles of substances, plant, materials and premises, which may affect their safety. Mock drills and reviewing the reports, safety reports and audits, on-site and off-site emergency plans, risk assessment reports, examination and reviewing of HAZOP, FMEA, FTA and ETA, etc. Some workplace activities may create or increase hazards, if they are not properly managed. These include purchasing policies, e.g. if the products, plant, materials and personal protective equipments that are selected are the cheapest one and are not safely designed, not suitable for the job or suited to the workers using it or are of inadequate quality, roles, responsibilities, and accountabilities, e.g. if they are not clearly defined. People will not know what they have to do, when or how to do it. It applies especially in emergency situations. Excessive physical and mental tasks and job demands which may lead to an inability to keep the worker's mind on the job. Organizational arrangements, such as shift work and rosters, may lead to fatigue and human error where workers are working for long hours, or are working more than one job. Levels of supervision and ratio of supervisors to workers, e.g. greater levels of supervision are appropriate in some areas. Key performance indicators, e.g. when set too high they create unrealistic performance targets, which can increase the worker's tendency to take shortcuts and increase risks while trying to achieve the targets. Maintenance and servicing programs for plant to cover wear and tear training programs, where risk management of property is emphasized over the risk management of people and safety. Economic drive. In recent years, accidents involving major accident hazards, MAHs, industries in India and overseas have resulted in numerous chemical disasters. Consequently, governments, chemical industries and communities worldwide are determined to prevent further serious accidents and considering the hazards beyond the plant premises to assess the impacts. Major accidents hazards, MAH. Industries such as oil refineries, chemical fertilizers, chemical plants and large fuel and chemical storage facilities where large quantities of hazardous materials are stored, handled or processed are governed by the manufacture, storage and import of hazardous chemicals, MS and IHC, Rules 1989 and subsequent amendments. Chemical accidents, emergency planning, preparedness and response, Rules 1996 under the Environment Protection Act 1986 have further advocate to protect people, property and the environment from chemical accidents. This will be achieved by applying safety obligations on everyone involved with the storage, process, transport and handling of hazardous materials. Central Motor Vehicle Rules 1989 also guides to identify and control the hazards. The Theme 2 deals with the details about the hazards, risk and control during transportation of hazardous chemicals. These regulations regulate MA industries to minimize the likelihood of accidents at these sites and to minimize adverse impacts off-site. This is achieved by assisting the operators of such facilities to meet their safety obligations, which include the provision of a systematic risk assessment, emergency plans and procedures, a safety management system, a program of induction, information, education, supervision and training for all persons at the facility, information to, and opportunities for, consultation with the neighboring community, a safety report and audit. The satisfactory fulfillment of these obligations are monitored and promoted by the regulatory agencies through a professional review and audit processes. The hazards due to release of any chemical is assessed by knowing the impacts zones both on-site and off-site by doing computer modeling and displaying the affected area on map. It requires scientific and technical understanding about the behavior of the chemical. Impact modeling and assessment, for example, of a toxic gas as shown in the figure and similar are needed for explosion and fire. The information gained is then used to facilitate land use planning decisions and in the emergency services to develop realistic emergency planning, preparedness and response mechanism.